Alrighty, let's do a little domain and range. And the same rules that we've used for domain and range, or same analysis, applies here. You really, domain, you're looking for under a square root, needs to be positive, can't divide by 0. Range, you're looking for, okay, what's varying here? And can I find a range of that? And then use that to find the range of the whole function. So let's do something that has an exponent that's a quadratic. So let's do d of x together. And first, thinking about the domain of this function, well, there's no restriction on when I can put in for x here, so the domain is going to be everything. So that's not the tricky part, but the range is a little bit more challenging. So as I just said, when you're thinking about the range, think about what is varying, what contains the variable, and that's the exponent. So the exponent's a quadratic, and this is going back to what we've learned in previous units. The range of a quadratic, and it's a quadratic that opens up, will be the y-coordinate of the vertex to infinity. So we've got to find that. And there's a few ways you can do that. You can either rewrite the quadratic in completed square form, or you can simply do negative b over 2a and plug it back in to find the y-coordinate of the vertex. Either way. So here maybe I'll do different than what I did on the answer key to find the x-coordinate of the vertex. Again, negative b over 2a. So the x-coordinate of the vertex is 2. And then the y-coordinate, I plug it back in. And let's see, I get 11 minus 8, which is 3. Okay, so that means when I'm analyzing my range, I've got this 2 as my base. The quadratic has a range from 3 to infinity. And then I've got this plus 1. Okay, so let's actually do it out. 2 to the third is 8. 2 to the infinity is huge, so infinity plus 1. So the whole range then will be 9 to infinity. So that's how you can go through the domain of something where the exponent is quadratic. Again, it's really no different in thinking about if you have something else in the exponent. So like, for example, when you go to f of x here, the domain, well, I do have a square root, so I just need to make sure that inside the square root is always greater than or equal to 0, which in this case will be always. There's no way that equals 0 or a negative, so the domain is everything. And then I do my analysis of the range. So I see that, I've got the base 2. The range of inside the square root, well, x to the 4th can be 0 to infinity. So it means inside the square root could be 9 to infinity. So that means when it comes out of the square root, it's 3 to infinity. And then I've got that that minus 3 is not up. It's minus 3 down here. Okay, so then let's now just do this. 2 to the third is 8. 2 to the infinity is infinity. And then I'm going to subtract 3 from each piece. So I'll get 5 to infinity. So my range would be 5 to infinity here. All right, let's do another together here. Looking at g of x, oh boy, I've got a polynomial inside the square root here. So first thing, because I have the square root, I need to do a little bit of analysis there. I need x plus 7 squared, 3 minus x plus 10 cubed, all to be greater than or equal to 0. So what does that mean? I'm doing a little sign chart. So I've got negative 10, negative 7, and 3. Let's see. Then this will be minus plus, not changing sign across, that looks like a 2, across negative 7 because it's squared. So my domain here will be negative 10 to 3. Okay, the range. Remember the range of a polynomial. So if I'm thinking inside the square root, all is about the end behavior. And so the end behavior, I can learn that from finding the leading term. So it's going to be negative x to the 6. So down, down. Which problem? So because I don't know what that high value is, so if I think about it, I've got 2. I do know because it's in the square root, the low will be 0. And then we've got this question mark finite number, minus 5. 2 to the 0 is 1, and minus 5 is 4. So it would be 4, comma, question mark. Can't find this. Because again, that's the case of that high value. All right, let's do one more. Now I have a rational function. National function in my exponent. So can't divide by 0 there. So the domain would be everything but negative 1/2. So negative infinity, negative 1/2, union negative 1/2 to infinity. Okay, so for the range, looking at this is, you can think of it I'm like covering it up here. Think of it a few different ways. When you can think about it, the k thing, if I set this exponent equal to k, what can it be? I can also think now of the work we did with EBAs. The EBA would be 3/2. In this case, it would never hit 3/2. So when I do my range analysis, it's 9 to the negative infinity to the 3/2 union 3/2 to infinity. Then I've got this plus 1. Okay, so 9 to negative infinity, really close to 0. Well, 9 to the 3/2, it means do the square root of 9, which is 3, and 3 cubed would be 27. Union 27, 9 to the infinity is infinity, and then you've got the plus 1. So our range here would be, if I'm adding 1 to everything, 1 to 28, union 28 to infinity. Okay, so that's a little bit of domain and range for you, incorporating the exponential piece, but with all the other parts we've done this year.